Standardization in machine learning. AI intermediate level. Introduction. In machine learning, datasets often contain features with different numerical ranges and distributions. For example, feature range: age 18 to 60, income 20,000 to 200,000. If features have very different scales, some machine learning algorithms may give too much importance to features with larger values, which can negatively affect model performance. To solve this problem, machine learning uses feature scaling techniques. One of the most commonly used scaling methods is standardization. Standardization transforms feature values so that they have mean equals 0, standard deviation equals 1. This helps algorithms learn patterns more effectively. Standardization is widely used in applications such as neural networks, support vector machines, logistic regression, clustering algorithms. Understanding standardization helps learners build stable and well-performing machine learning models. What is standardization? Standardization is a feature scaling technique that transforms numerical data so that the resulting distribution has a mean of 0 and a standard deviation of 1. In simple words, standardization equals transforming data so it is centered around 0 with unit variance. Example concept: different feature scales means standardization means centered dataset. This transformation makes features easier for machine learning algorithms to process. Z-score formula. Standardization uses the Z-score formula to transform values. Z equals X minus mu sigma. Z equals sigma X minus mu X mu sigma Z equals X minus mu sigma approximately equals 1.2. Z equals sigma X minus mu approximately equals 1.2. Phi Z approximately equals 88.5%. Phi Z approximately equals 88.5%, where X equals original value, mu equals mean of the feature, sigma equals standard deviation, z equals standardized value. Example concept: original value means subtract mean means divide by standard deviation. This transformation shifts the distribution so that it is centered around 0. Why standardization is important? Many machine learning algorithms assume that input features follow a normal distribution. If features have very different ranges, algorithms may behave incorrectly. Example concept: uneven feature scales means unstable learning. Standardization helps improve model accuracy, speed up gradient-based optimization, stabilize machine learning training, balance feature influence. It ensures the model treats all features equally. Example of standardization. Example dataset. Feature value 10, 20, 30. Assume mean equals 20. Standard deviation equals 10. After standardization, standardized value -1, 0, 1. Example concept: raw values means centered values around 0. This makes the data easier for algorithms to process. When to use standardization? Standardization is commonly used with algorithms that rely on distance or gradient calculations. Examples include support vector machines, SVM, logistic regression, neural networks, k-means clustering, principal component analysis, PCA. Example concept: optimization algorithms means benefit from standardized data. These algorithms perform better when features follow similar distributions. Standardization versus normalization. Standardization and normalization are both feature scaling techniques but serve different purposes. Method result use case. Normalization range between 0 and 1 distance-based models. Standardization mean equals 0. STD equals 1 algorithms assuming normal distribution. Example concept. Normalization means bounded range. Standardization means centered distribution. Choosing the right method depends on the dataset and algorithm. Advantages of standardization. Standardization provides several benefits. Advantages include: stabilizes gradient descent algorithms, improves model convergence speed, prevents dominance of large value features, works well with normally distributed data. Example concept. Balanced feature distribution means stable learning. These advantages make standardization widely used in machine learning pipelines. Limitations of standardization. Despite its usefulness, standardization has some limitations. Limitations include: sensitive to extreme outliers, assumes roughly normal distribution, may not be ideal for heavily skewed data. Example concept. Extreme values means affect mean and standard deviation. In such cases, other scaling techniques may be used. Example Python code. Standardization can be implemented using scikit-learn. Import the scalar from sklearn. Preprocessing import standard scalar. Apply standardization. Scalar equals standard scalar. X underscore scaled equals scalar.fit underscore transform. X. This converts features into standardized values. Standardization workflow in ML. Standardization is typically applied during data preprocessing. Example workflow. Raw dataset. Down pointing arrow. Data cleaning. Down pointing arrow. Feature engineering. Down pointing arrow. Standardization. Down pointing arrow. Train machine learning model. Scaling ensures the dataset is properly prepared for training. Real-world applications. Standardization is widely used in AI systems. Finance. Standardizing financial indicators for credit risk models. Healthcare. Scaling patient data for disease prediction. Marketing. Standardizing customer analytics data. Image processing. Normalizing image features before training deep learning models. Robotics. Processing sensor measurements for AI models. Concepts learned from standardization. Understanding standardization helps learners understand. Checkmark how feature distributions affect machine learning algorithms. Checkmark how the z-score formula works. Checkmark how scaling improves optimization algorithms. Checkmark how standardized features improve training stability. Checkmark how preprocessing improves machine learning performance. Standardization is an essential technique in data preprocessing and feature scaling. Simple definition. Standardization. A feature scaling technique that transforms numerical data so that the feature distribution has a mean of 0 and a standard deviation of 1. Final summary. Standardization is a widely used feature scaling technique in machine learning. By transforming data using the z-score formula, it ensures that features are centered around 0 with a standard deviation of 1. This allows machine learning algorithms to learn more effectively, especially those relying on gradient descent or distance calculations. Standardization plays a critical role in preparing datasets for machine learning models and is commonly used in many real-world AI systems. Understanding standardization is essential for anyone learning machine learning, data science, and artificial intelligence development.